Hello, my dear students. Welcome back to the lecture. So, in this lecture, we will see how to do the Excel sheet for the two-way slab. Okay. So, this is an example of what I had taken for the two-way slab, where my length is 5,000 and the breadth is 5,000 and the length is 7,000. Okay. So again, first we'll start with the main bar along the shorter span. So we have to find the cutting length for this. So how we are going to find? You know it. So 230 minus 25 plus this is 5,000 minus this crank length is how much? 5,000 divided by 4 is 1250. So this will be 3955. The straight length is 3955. This crank is 0.42 into h, so it comes out to be 42. And the top straight, this is L by 4, that is 1250 plus 230 minus 1 cover. Same thing I've done it here. The rest thing you know. Then number of member is 1, dia is 10. Spacing is how much here? Yeah, 200. So the number of bar will come out to be how much? See here, the number of bar will come out to be 36 numbers because opposite length is your 7,000 divided by 200 plus 1. This will be 36 number of bar. So cutting length will be, you add everything, 3955 plus 42 plus 1455 minus bend deduction 2t. So minus 2 into 1 into 10 will give you 5432. So in meter it is 5.432. So the total cutting length will be 5.432 into 36 into 1. So it is 195.552. Since it's a 10 diameter bar, 195.552 into 0.617, this will give me 120.656. Got it? Now, the main question is that, okay, so along the shorter span I have done, no? Okay, I told I'll explain you for this. Wait, okay. No problem. We'll continue with this only. When I go with the live project, then I'll explain you for the alternate side. Okay, this is understood, right? Good. Now we'll go to the longer span. The shorter is done. Now come to the longer span. So manually also how much I had got? 5432 I got. Same thing I got here. Now again, this is your longer span bar. This one. Okay, since it's a two-way slab, it will be like this. It will go like this, right? Yeah. So again, this straight portion I want to find. This straight portion I want to find. This portion from here to here. So it will be how much? 230 minus 1 cover plus 7,000 minus this crank length. So crank length will be minus 1750. So this will be 5455. 5455 is this length. The crank is 42 into 0.42 into h. But here, since it's a two-way slab, you remember 0.42 into 90 we are supposed to do. So same thing we are done in manual calculation because you have to deduct the bottom rebar, that is a shorter span bar, which is a 10 diameter bar. Then the straight portion, that is a crank portion you're supposed to take. So crank is 1750 from here to here plus 230 minus 1 cover. Same thing I've done it here. And I've given a name, main bar along longer span. 1, dia is 10, spacing is 200. So the number of bar will be 5,000 because opposite length is 5,000 divided by spacing plus 1. So it will be 26 number of bar. So cutting length, you add everything, 5455, 37.8, 1955 minus 2d bend deduction. If you do, you are getting 7427.8. So it is 7.427 in meter. Total cutting length will be 7.427 into 26 into 1. So it will be 193.1228. And since it's a 10 diameter bar, 193.1228 into 0.617 will give 190. So whatever I have done, everything we have got it manually. See here. How much you got here? Cutting length 7.427. Same thing you got here. Number of bar you got 26. Same thing we got here. Understood, right? This is done. Now come to the crank distributor. So crank distributor, again I'll go and take that and come. Okay. This was your crank distributor part, isn't it? Yeah. Yeah. Fine. So next is crank distributor. Okay. So this length is how much? 7410. How it is? Because 7,000 is a length plus 230 on this side 230 on the other side, minus 25, minus 20. Whatever manual calculation we are doing, same thing only I'm doing. 7410. See here, you got 7410. So crank distributor bar along the shorter span. So one, it's a 10 diameter bar. Spacing is 200. So number of bar. So you are putting along this span. You have to take the opposite length. So L by 4, that is 5000 divided by 4 will be 1250. 1250 divided by 200 plus 1 you do. And you round it up. But we want to find the crank on both the sides. So this answer I'll multiply by 2. You get the 16 number of bar. So manually also you have got 16 number of bar. Excel sheet also we got 16 and 16. Got it, no? Fine. So cutting length is 7.41. So the total cutting length will be 7.41 into 16 into 1. This will be 118.56. And since it's a 10 diameter bar, 118.56 multiplied by 0.617, this will be 73.15. Got it? So crank distributor along the shorter span is done. Since it's a two-way slab, your crank distributor will come along the longer span also. Right? So that we'll do now. So again, this will be 5000. So 230 width plus straight was 5000 plus 230 minus 1 cover from here minus 1 cover from here. You're getting my point, right? So 5410 manually also we got 5.41. See here 5.41. In case you are not able to understand something from the Excel sheet, go back to my previous lecture and learn from there. Okay, because there I've explained you like a baby. For a small kids, how we explain, in that way I've explained you. Now since it's Excel sheet, you just need to apply your brain like what you're trying to do. Okay, fine. So number of member is 1, dia of the bar is 10, spacing is 200. Now come to the number of bar. Okay, so number of bar will be, you have to take opposite length. Since you're putting it along this way, so you'll take 7000 divided by 4. Your crank length will be 1750. 1750 divided by 200 plus 1 you do. You'll get around 10 number of bar. Since I want to find the crank on both the sides, this side, left side and right side, I'll multiply this by 2. So you'll get 20 number of bar. Same thing, we got it here, 20 number. So cutting length you got 5.41. So total will be 5.41 into 20 into 1. This will give me 108.2. And since it's a 10 diameter bar, 108.2 into 0.617 will give me 66.75 kg. Got it? So whatever slab we were supposed to find, we have done it. 90% of my calculation is done. The last portion which is left out, that is my top extra bar on both the side. First, I'll go with the shorter span bar, top extra. So 1250 is L by 4. Okay, 5000 divided by 4 is 1250 plus 230 is the width of your beam minus 25 is a cover. So the cutting length is 1455. So let me take that also now. Yeah, this portion. Okay, fine. So number of bar is dia of bar is 10. Okay. Now spacing I've written 400 here, or I could have written 200 also. Then I shouldn't multiply by 2. I shouldn't do. If I write here 200, in the number of bar I shouldn't multiply it by 2. Or simple method is you write 400 only, because spacing will get double in terms of top extra bar. So I written 400 because main bar was 200. So here it will be 400. Okay, good, fine. So this cutting length you understood. Spacing is known. Number of bar will be how much? Number of bar will be, always remember, since it's a two-way slab, you'll not take 7500 divided by 4. So your crank, this top extra bar will be put only in the L by 2 portion. So it is 3500. That is 7000 divided L by 2. 7000 divided by 2 is 3500 divided by 400. You do that. Okay. And then close this thing. What is that? Bracket and multiply it by 2. Yeah. One thing I forgot to tell you. See, when you provide this top extra bar, no, again you don't have to do plus 1. Okay, I'll do it. I'll explain you here. Yeah, I think here, or else I'll explain you here only. Yeah, this top extra bar we had put only in this direction, isn't it? This direction we had put top extra bar. This one. Like this, we had put top extra bar, which was at L by 2 in this way. Similarly, here we had done that. Okay, fine. So you'll not do the plus 1 here. Why? Because already when you are finding this crank distributor, you are done the plus 1. Here also you are done plus 1. Here also you are done plus 1. So again, you don't have to do the plus 1 for here, because then what will happen? Your number of bar will increase unnecessary. Because if you remember, if I wanted to find top extra bar right from here, let us consider right from here, how many times plus 1 you would have done? Only once you would do, right? Whatever answer you get, plus 1 we were doing once. But here we have broken down, like the crank distributor separately we had calculated, and plus 1 we had done. And then after that, for top extra bar, again you will not do the plus 1 here. Now you'll ask me, so what will happen if I do plus 1? Nothing will happen. One number of bar will increase, but practically that much number of bar on site we cannot provide. Okay, so you don't do plus 1 in this case. So that is the reason we don't do plus 1 here. See here, number of bar, I didn't do plus 1. Okay, because you will not add a plus 1 every time. That is the reason, because already crank distributor plus 1 we have done. If you remember the beam case, when we were finding the number of stirrup at 100 center to center spacing and the center 150. So I told you, either you do at the support or you do at the center. You shouldn't do on both the side. Near the support also you'll add plus 1. Near the center also, if you add plus 1, practically nothing will happen. On the Excel sheet, your steel will increase. On practically on site, that much number will not happen. For example, see, now actually 18 number of steel I'm getting. Okay. Manually also, I think, yeah, we got 18 only manually. Now, if I do plus 1 here, nothing will happen. You see the steel difference also. You're getting a 16.15 kg. If I do plus 1, we'll see what happened. Okay, wait. Okay, this will not, it won't take that. I'll do that. I close the bracket here. I'll open one bracket here. Okay, wait. Uh, okay, now it will, yeah, now it is fine. No, it's not a round up. Okay, okay, wait. So two open bracket, two close bracket is there, no? Yeah. See now? Okay, it is coming 17.6. How much it was earlier case? Wait, 11. No, then we have done one mistake. No, no, it's correct. No, 11, correct. 400 is the spacing. Huh. 11 bar it is coming. How much you got here? Wait, 18 we were getting. No, I'll do this round up. This one divided by, okay, okay, plus 1 we are supposed to do here. No, sorry, plus 1 I'll do it here. Yeah, see, 20 you got now, right? Previously you got 18. Since I did plus 1, 2 bar extra came. Because of that, 17.95. I'll show you the differences. 17.95. This is the answer we're getting. Okay, 17.95. If I keep only 8, 17, okay. How much it was? 17.95 minus, this is 16.15. Okay, minus, wait, minus 16.15. If I do that, so roughly 1.8 kg extra steel is gonna come. And practically on the side, you cannot keep 20 top extra bar. It will be 18 only. Maybe either 18 or 19, but 20 will never come. Okay. Depends on site condition. So that is the reason. Don't add plus 1 here. Okay. If you add, no problem. Nothing will happen. Don't think that you are gone wrong. You are little overestimating the state, and that is fine. Always overestimating is little good, because so that there won't be shortage of a steel when you procure the steel. But too much of overestimation also should not happen, and too much also less estimation should not happen. So whatever we have done is correct. If you feel like, sir, this is a very minor changes what we are doing, no problem, go with that. You add plus 1, but not a right way of doing. That's it. Okay, fine, done. Now come here. So this is done. No? This part is closed. Now the last part is your this thing, which is that along the longer span. So longer span 1750, 7000 divided by 4 is 1750, plus 230 is a beam width, minus 1 cover is cutting length is 1955. Manually also we had got 1.955, 1955. So 1.955 we got. Now spacing is 400. So number of bar. So number of bar. So 5000 divided by 2 you are supposed to do. So it will be 2500. Divide by spacing is 400. Close the bracket and multiply it by 2. Plus 1 I did not do here also. So it will be 14 number of bar. Manage here we got 13. Okay, actually we should have added plus 1 here. I told you in manual calculation that 14 was the answer we got. So practically 14 we got. Again, if you want to add +1, you can add. Slight increase in the steel will come, and that is fine, not an issue, but not the right way of doing. So again, if I multiply this 27.37 into 0.617, it will give me 16.88 kg of a steel is required. So this is almost 16.15, this is almost 16.88, right? And almost you see the steel, both are same, okay? Here the length has decreased, but here number is 18. Here length is more, number is less. So that is the reason almost same amount of steel you're getting. Got it? So if you ask me, sir, what is the total steel that is required in this two-way slab? Finish. The total steel required will be, I've done the calculation, add all this steel which has come in your 10 diameter column. So 414 kg of a steel is required. So how much? 414 kg of a steel is required. Got it? In a two-way slab. Now, I'll tell you one small thumb rule. Actually, this cannot be a thumb rule, but still. So in one-way slab, you got 158 kg of total steel. In two-way slab, you got 414, almost 2.5 times of that we have got, because here both the side top extra and crank will come. Now, what was the area of your slab? This was your almost a 3 meter by 5 meter slab. It was a 3 meter by 5 meter slab. So total area was 15 square meter. So if you ask me per square meter, what is the steel consumption here? So what you do, 158 is the total steel divided by the area you do. That is 15 area, 15 square meter. So almost 10.55, let us say 11 kg of a steel. 11 kg of a steel is required per square meter. So this is a kind of a thumb rule for a one-way slab. For a two-way slab, your length was 5 meter by 7 meters. So I've taken 35 square meter. Again, if I do that, 414 is the total steel required, divided by 35. So almost 12 kg of a steel is required per square meter. Okay, per square meter, 12 kg of a steel is required. So this is a rough idea of understanding how much consumption of a steel will happen. But again, this is not a thumb rule for now. Why? How do you prepare a thumb rule? You prepare a thumb rule when you have different sets of data. But right now, I took only one plan. For this plan, I cannot say this is a thumb rule. But if I taken 10 different plans like this, for example, I'll do it in a live project. I'm giving an idea. Suppose this is one plan I have. Similarly, I have a 10 plan of a 10 different building. And then I take all the value, and then if I find, okay, then if I find then if I find for the project number one, for the project number one, I'm getting 450 kg. For project number two, I'm getting, let us say, 500 kg. For 500 kg. For the project number three, I'm getting, let us say, 475 kg. For the project number four, I'm getting 520 kg. Then if I do the average of this, these are the set of values I'm getting, and then I can create my own thumb rules. So thumb rules will come when you have a lot of data. But just to give an idea, if you're working on some project, try to create your own thumb rule. How do you create? Try to keep all the track of all these values what you have got, and then you can take an average of this. Then you can come to a conclusion. If I'm doing a one-way slab, roughly 10 to 12 kg of a steel will be gone per square meter. If it is a two-way slab, roughly let us say 14 to 15, or let us say 12 to 15 kg of a steel will be consumed per square meter. So that is how the thumb rule come into play. Okay, thumb rule will come into play only when you have large set of values with you, right? Simple. Good. So I hope up to here you have understood the concepts. You understood how to put all these values on the Excel sheets. So in the next lecture, we'll take up this particular live project of a two-way slab and one-way slab, and we try to do it. Okay. So it's very simple. How we try to do this is we break it down in the slabs. This is slab number one. Whatever I taught you, this is one slab. I'll do the BBS for this. I'll do the BBS for this separately. I'll do the BBS for this slab separately. I'll do the BBS for this slab separately. So in this way, each slab, whatever I have, I'll do the BBS separately, and I'll get the total steel consumption that is required in this particular building. Got it? Great. So try to practice up to here. Try to prepare Excel sheets, because next this same Excel sheets I can use and just change the values, and within a fraction of second I'll get my answers. So if you don't have your Excel sheets ready, manual calculation will take long time. That is the reason create your own Excel sheets. Okay. And the next lecture we'll try to solve all these things. So we'll see you back in the next lecture. Thank you.